What if everything you learned in history class was wrong? What if the story of human civilization didn't begin with us slowly crawling out of caves, learning to farm, and gradually building the first cities? What if instead we inherited our knowledge from someone else entirely? Someone who vanished before recorded history even began, leaving behind only whispers in stone and shadows in ancient texts that scholars have been desperately trying to explain away for over a century. Tonight, we're diving into one of the most controversial questions in archaeology. A question so unsettling that it threatens to rewrite everything we think we know about our past. Because scattered across the globe, buried in museums and hidden in plain sight, lies evidence that human civilization might not have developed naturally at all. Evidence that points to something far more extraordinary and far more disturbing than gradual human progress. If you've ever wondered why ancient peoples across the world built monuments that still baffle modern engineers, why they possessed mathematical knowledge that wouldn't be rediscovered for millennia, or why their oldest stories all speak of teachers who came from the sky, then you're about to discover why some archaeologists are quietly questioning everything they've been taught about human origins. Hit subscribe because what we're about to uncover will change how you see every ancient ruin, every mysterious artifact, and every creation myth you've ever heard. The evidence has been waiting in silence for over 5,000 years, and it's time someone finally listened to what it's trying to tell us. The first crack in our understanding of human civilization appeared in 1922, buried beneath the shifting sands of Iraq. British archaeologist Leonard Woolley was excavating what should have been humanity's fumbling first attempts at city building. He expected to find crude walls, primitive pottery, and all the messy trial and error that comes with learning to live together in large groups. Instead, he found something impossible. 6 feet down, where archaeological logic said there should be scattered bones of societies learning to organize themselves, Woolley uncovered perfection. Streets laid out in precise mathematical grids. Drainage systems that would make modern civil engineers pause in admiration. Walls that ran straight and true for hundreds of yards. Their foundations cut deep into bedrock with the confidence of builders who had never known failure. This was supposed to be one of humanity's first experiments with urban living, but it looked like the work of people who had been building cities for centuries. There was no learning curve, no gradual improvement, no archaeological debris of countless failed attempts that should litter the path from nomadic life to complex civilization. Woolley lifted a clay tablet from the excavated dirt. What he held in his hands wasn't a primitive scratch of someone learning to write. It was a bureaucratic masterpiece. Tax records written in neat columns, cataloguing grain shipments and livestock inventories with an efficiency that wouldn't look out of place in a modern office. The mathematical calculations were flawless. The organizational systems were sophisticated. The quality of the work was extraordinary, and it was 5,000 years old. Standing in that excavation pit, surrounded by evidence that made no sense according to everything archaeology had taught him, Woolley felt the first crack appear in humanity's origin story. Because cities aren't supposed to emerge fully formed. They're supposed to stumble into existence over generations, leaving behind layers of mistakes, collapsed experiments, and gradual improvements that archaeologists can trace like rings in a tree. But here, beneath millennia of sand, lay what looked like a blueprint that had skipped the learning process entirely. As if someone had drawn up plans for an entire civilization and then built it in a single coordinated effort. The pattern repeated itself everywhere Woolley and his colleagues dug. At Uruk, they uncovered a metropolis that once housed nearly 80,000 people, complete with specialized districts for craftsmen, merchants, and priests. Monumental structures rose from the city center like geometric mountains, their construction requiring architectural knowledge that should have taken centuries to develop. Administrative archives contained complex legal documents. Schools taught standardized curricula to young scribes. Workshops produced goods according to specifications so precise they suggested industrial-level quality control. All of it appeared simultaneously around 3200 BCE, as if someone had pressed play on a civilization that was already fully designed. But designed by whom? And what had happened to the original architects? The mathematics alone defied every model of human development. The Sumerians hadn't stumbled onto a working number system through trial and error. They had created something elegant and sophisticated. Their base 60 mathematical framework allowed for complex calculations involving fractions and large numbers. A system so advanced that we still use it today when we divide hours into minutes and circles into degrees. This wasn't the kind of practical counting you develop while tallying sheep or measuring grain. This was theoretical mathematics, the product of minds that understood abstract principles that our own civilization wouldn't rediscover until the Renaissance. How had Bronze Age people developed mathematical concepts that would challenge university students today? And then there was the astronomy. Night after night, Sumerian observers had tracked the movements of planets across the sky with an accuracy that seemed impossible without telescopes. They knew Venus was a single object, whether it appeared as the morning star or evening star, something that confused other civilizations for millennia. They distinguished Saturn from surrounding stars, despite its barely visible glow. They predicted eclipses and calculated celestial cycles with mathematical precision. Where had they learned to read the sky with such sophistication? Who had taught them to recognize patterns in the darkness that took other cultures thousands of years to discover? The mystery deepened when archaeologists examined the foundations of their achievements. At Eridu, the city the Sumerians themselves claimed was the first ever built, excavations revealed 17 construction layers, each built directly on top of the last. But these weren't the random additions you'd expect from a building that evolved over time. Each layer followed the exact same architectural plan, the same proportions, the same orientation, the same careful attention to astronomical alignments. 17 times across centuries, builders had climbed these steps, measured these angles, and laid these foundation stones with absolute precision. 17 times they had chosen complete fidelity over innovation, preservation over progress. It was as if they were terrified of forgetting something crucial, as if they were following instructions they couldn't afford to deviate from, no matter how many generations passed. But instructions from whom? The conventional story taught in every classroom sounds reasonable enough. Around 3500 BCE, nomadic tribes settled in the fertile valley between the Tigris and Euphrates rivers. Agricultural surplus led to population growth, which created the need for social organization, which eventually resulted in civilization. It's clean, logical, and fits comfortably in textbooks. But when archaeologists dug past the surface, the evidence began to resist this tidy narrative. Where were the failures? Where was the experimental phase when humans were supposedly figuring out how to be civilized? Every other culture in history left behind clear archaeological trails of learning. Pottery that gradually improved, tools that slowly evolved, buildings that grew more sophisticated over generations. In Sumer, the earliest layers accessible to archaeologists already showed remarkable sophistication. The first cuneiform tablets weren't primitive scratches. They were standardized records written in organized script, complete with mathematical calculations and legal terminology. The earliest irrigation channels weren't simple ditches. They were engineered waterways with locks, gates, and distribution systems that demonstrated advanced understanding of hydraulics and water management. It was as if the Sumerians had begun their civilization at version 5.0. Never bothering with the messy process of learning what version 1.0 should look like. Perhaps most unsettling was what archaeologists found beneath Sumer's foundations, or rather, what they didn't find. In the deepest layers they could reach, they discovered not the ancestors of Sumerian civilization, but absence. Not the natural emptiness of uninhabited places, but something that felt deliberately cleaned, swept, prepared. It was like walking into a house where someone had carefully removed all the family photos, leaving behind only faint outlines on the walls where frames once hung. The Sumerians themselves seemed aware of this emptiness. Their creation myths didn't describe civilization's gradual development through human ingenuity. Instead, they told stories of knowledge being delivered complete and perfect by beings they called the Anunnaki, a term that translates as those who came down from heaven. The word choice is telling. Not those who always were, or those who emerged from among us, but those who came down. The language suggests arrival rather than origin, contact rather than creation. According to these ancient texts, the Anunnaki taught humanity the fundamental arts of civilization: writing, mathematics, astronomy, engineering, agriculture, and law. Every innovation appeared simultaneously in the archaeological record, as if someone had downloaded an entire cultural operating system into human consciousness. Most scholars interpret these myths as symbolic representations of humanity's tendency to attribute mysterious knowledge to divine intervention. But what if the Sumerians were describing something else entirely? What if they were preserving memories of actual instruction, not from gods, but from teachers whose origins had been forgotten by the time the first tablets were written? The myths describe something the Sumerians called the Me, often translated as divine laws or cosmic principles. But these weren't abstract concepts. They were specific knowledge packages that weren't created but recovered, retrieved from chaos, restored to order, rebuilt from memory. That word rebuilt echoes through Sumerian literature like a confession. They weren't inventing civilization. They were reconstructing it from fragments of something that came before, but reconstructing it from what, and based on whose memory? Standing among the ruins of these ancient cities today, you can feel the weight of these questions pressing against the boundaries of accepted history. The mathematical precision of the walls, the perfect alignment of the temples, the sense that everything was built according to plans drawn by architects who are no longer available for consultation. And in the silence that has persisted for over a century since Woolley's first discoveries, you begin to understand what's really missing from our story of human civilization. We're not looking at humanity's first cities. We might be looking at humanity's first reconstruction project, which means somewhere, buried deeper than we've yet dared to dig, lie the blueprints for everything we think we invented ourselves. The original plans for civilization, waiting in the darkness like a door we're not sure we want to open. Because if Sumer wasn't the beginning, if it was just the first attempt to rebuild something that came before, then every assumption we've made about human history might be fundamentally wrong. All of it might be nothing more than echoes of a memory we've been trying to forget. The implications stretch far beyond archaeology. If we inherited our civilization rather than developed it, what happened to our teachers? If knowledge was delivered rather than discovered, who decided what we should learn and what should remain hidden? And if we're living in humanity's second attempt at complex society, what destroyed the first? These questions have been waiting in museum storage rooms and university archives for over a century, waiting for someone brave enough to ask them out loud, waiting for minds willing to consider that the story we've been told about our origins might be incomplete. Because the evidence is there, scattered across archaeological sites, encoded in ancient texts, and built into monuments that still challenge our understanding of what Bronze Age people should have been capable of achieving. The pattern is too consistent to ignore, too sophisticated to explain away, and too important to dismiss as coincidence. Human civilization appeared too quickly, with too much knowledge, possessing capabilities that seem to exceed what gradual development could account for. And if that's true, then we need to ask the most important question of all. If we didn't develop our civilization naturally, who did we inherit it from? The answer to that question is waiting in the next part of our investigation. hidden in tablets that scholars have been quietly trying to explain away for decades. Because what we're about to discover will challenge not just our understanding of the past, but our assumptions about what it means to be human in the first place. The answer began revealing itself in 1956, deep in the basement archives of the University of Pennsylvania Museum. Professor Samuel Noah Kramer had spent 3 decades translating cuneiform tablets, coaxing meaning from the bureaucratic whispers of a dead civilization. Tax records, marriage contracts, grain inventories, the mundane poetry of people learning to organize their world with scratches in clay. But the tablet trembling in his hands was different, not because of what it said, but because of how impossibly well it said it. Every wedge-shaped mark pressed into the clay with surgical precision. Every symbol following grammatical rules so sophisticated they wouldn't be out of place in a modern linguistics textbook. Every line organized in columns that demonstrated not just literacy, but institutional memory codified in clay. Carbon dating placed this tablet at roughly 3200 BCE, making it one of humanity's earliest attempts at written communication. Except it didn't look like an attempt. It looked like a masterpiece. How do you invent perfection on the first try? The question had been haunting Kramer for years, growing louder with each tablet he translated. Because cuneiform wasn't just functional, it was elegant, not just communicative, but systematic. A fully realized technology for capturing human thought, deployed with the confidence of people who had never seen writing fail, and that confidence disturbed him most of all. Languages are supposed to stumble into existence. They begin as grunts and gestures, evolve into words, gradually develop grammar, slowly learn to represent abstract concepts. Writing systems should show even more evolutionary debris. The archaeological remains of people figuring out how to make marks represent sounds, how to organize symbols into meaning, how to transform the chaotic flow of human speech into something that could survive on clay. But the Sumerian record was surgically clean. Walking through the museum's archives, past row after row of tablets stretching into the shadows, Kramer faced an impossible fact. Humanity's oldest writing system showed no signs of being young. He pulled another tablet from its protective housing, a legal document from Lagash dealing with water rights between neighboring cities. The language was dense with technical terminology, legal precedents, and bureaucratic protocols. The syntax was flawless, the vocabulary precise enough to handle complex negotiations involving multiple parties, standardized measurements, and conditional clauses. This wasn't primitive communication. This was institutional sophistication, crystallized in clay. The conventional story taught in every archaeology classroom goes like this. Around 3200 BCE, Sumerian merchants needed to track increasingly complex transactions. Necessity mothered invention. Simple pictographs gradually evolved into abstract symbols. Over time, these symbols began representing sounds instead of objects. Eventually, you have writing. It's clean, logical, and completely wrong. Because pictographs, when they exist in the archaeological record, don't show gradual evolution into cuneiform. They show up sporadically, inconsistently, with no clear developmental relationship to the sophisticated script that emerges fully formed around 3200 BCE. It's like finding a few random sketches and claiming they explain the Sistine Chapel. The evolutionary stages are missing. The transitional forms don't exist. The obvious mistakes that should litter any learning process are absent from the record. Just perfection appearing from nowhere, like a door opening in a wall you didn't know was there. Kramer returned to his desk and opened his translation notes, pages upon pages of careful analysis that had consumed decades of his life. The more he studied Sumerian grammar, the more convinced he became that these scribes weren't inventing a writing system. They were following one. The language showed structural sophistication that seemed impossible for a first draft. Verb conjugations that handled subtle temporal relationships. Most languages take millennia to develop. Noun classifications that revealed deep philosophical thinking about the nature of reality. Syntactic rules flexible enough to express everything from mundane accounting to cosmic poetry. All of it appeared simultaneously, as if someone had downloaded an entire linguistic operating system into human consciousness. He pulled up his translations of the earlier school tablets. Exercises from the Aduba, the Sumerian tablet houses, where young scribes learned their craft. But even these educational materials troubled him. Students weren't experimenting with new ways to represent sound and meaning. They were memorizing thousands of lines of predetermined text. Mathematical tables, legal formulas, religious hymns, astronomical observations, education as preservation, not exploration. What were they preserving? And why did preservation feel so urgent? In the growing darkness of the archive, Kramer found himself thinking about silence, the particular quality of quiet that fills spaces where important things have been deliberately removed. It was the same silence he'd noticed in the archaeological record beneath the earliest cuneiform tablets. No practice runs, no experimental symbols, no evidence of a civilization learning to write. Just absence. And then suddenly, perfection. The Sumerians had a word for their writing system, Sa. It meant to write, but also to place in order and to remember. The same root appeared in words for preservation, restoration, and reconstruction. As if writing itself was not about creation, but about preventing something from being lost, not invention, salvation. Kramer closed his eyes and tried to imagine the first Sumerian scribe sitting in some long-buried chamber, pressing a reed stylus into wet clay. What had that moment felt like? The thrill of discovery, the satisfaction of invention, or the weight of responsibility, knowing you were the last link in a chain that stretched back to teachers whose names had already been forgotten? Because the more he studied these tablets, the more convinced he became that cuneiform wasn't humanity's first writing system. It was humanity's first backup drive. The myths supported this interpretation. Sumerian creation stories didn't describe writing being invented. They described it being recovered. The ME, those cosmic principles that governed civilization, weren't created by humans. They were retrieved from chaos, restored to order, transmitted by the Anunnaki, those who came down from heaven to preserve knowledge that might otherwise be lost. Most scholars interpreted these myths as symbolic explanations for cultural innovation. But sitting in that archive, surrounded by tablets that whispered of knowledge too perfect to have been learned from scratch, Kramer began to wonder if the Sumerians were describing something more literal. What if they weren't writing creation myths? What if they were writing user manuals? Instructions for preserving knowledge that was already ancient when the first cuneiform tablet was pressed. Guidelines for maintaining systems that had been designed by minds the Sumerians could remember only in fragments and metaphors. He opened another tablet. Astronomical observations that tracked planetary movements with mathematical precision that wouldn't be matched for thousands of years. The same scribes who recorded grain shipments were mapping the cosmos using a writing system sophisticated enough to handle both mundane accounting and celestial mechanics. From day one. What kind of culture invents writing and immediately points it toward the stars? The kind that isn't inventing anything. The kind that's trying to remember. The silence in the archive pressed against him like a weight. Thousands of tablets. Millions of carefully pressed symbols, centuries of preserved knowledge, all of it feeling like an echo of something larger that had been speaking in a voice we could no longer hear. And then cuneiform simply vanished from history. Not gradually, not through evolution into other scripts, but cleanly, as if its purpose had been fulfilled, as if the backup process was complete. Kramer sat back in his chair and let the question form, that would haunt him for the rest of his career. If the Sumerians were preserving rather than creating, what exactly were they trying so desperately not to forget? Because somewhere in the silence before the first tablet, something had been worth preserving. Something important enough to encode in wedge-shaped marks and bury in desert sand for future civilizations to discover. Something we might still be trying to remember, one translated symbol at a time. And if that was true, if the world's oldest writing system was actually a preservation project disguised as an invention, then the real question wasn't how the Sumerians learned to write. It was who taught them what to remember. The night sky above Mesopotamia in 3000 BCE was darker than anything we can imagine now. No light pollution, no artificial glow washing out the stars, just infinite blackness punctuated by thousands of points of light. Each one a mystery waiting to be solved by minds that had never seen a telescope, never held a compass, never even conceived of the wheel. Dr. Hermann Hunger knew this darkness intimately. He had spent 40 years studying ancient astronomy, translating Babylonian star charts in the climate-controlled silence of Vienna's Academy of Sciences. But on this particular evening in 1998, as he held a photograph of a tablet that would change everything he thought he knew about human civilization, Hunger felt the same vertigo that must have gripped those ancient skywatchers as they realized they were staring into infinity. The tablet was catalogued as VAT 4956, a Babylonian copy of much older Sumerian observations. But what made Hunger's hands tremble wasn't its age, it was its accuracy. The tablet contained a complete astronomical diary for the year 568 BCE, with detailed observations of planetary positions, lunar phases, and stellar configurations. But buried in those calculations was something that shouldn't exist. Mathematical precision that matched modern values to within fractions of a second. The synodic month, the time between successive full moons, was recorded as 29 days, 12 hours, 44 minutes, and 3.3 seconds. Modern astronomy puts it at 29 days, 12 hours, 44 minutes, and 2.9 seconds, a difference of less than half a second, calculated by people who measured time with water clocks and shadows. Hunger set the photograph down and walked to his office window, staring out at the Vienna skyline while a question formed that would haunt him for years. How do you achieve that level of precision without instruments that won't be invented for 3,000 years? Because this wasn't just one lucky guess. The tablet represented the culmination of astronomical traditions that stretched back to Sumer, a continuous chain of observation and calculation that began when writing itself was barely a few centuries old. And every link in that chain showed the same impossible characteristic: accuracy that exceeded the tools available to achieve it. The Venus observations were the most troubling. Venus doesn't behave like other celestial objects. It disappears from the sky for weeks at a time, shifts dramatically between morning and evening appearances, and follows an 8-year cycle so complex that most ancient cultures never recognized it as a single planet. The Greeks called it two different stars, Phosphorus and Hesperos, and didn't realize their mistake until the 6th century BCE. But the Sumerians knew. Not only did they understand that the morning star and evening star were the same celestial body, they tracked its complete cycle with mathematical precision. The Venus tablet of Amisaduqa, copied from older Sumerian sources, recorded 21 years of Venus observations with data so accurate that modern astronomers use it to date ancient chronologies. How does a civilization that's just learning to write immediately begin mapping one of the most complex planetary motions visible from Earth? Hunger pulled up his translation notes, pages covered with careful analysis of cuneiform astronomical texts. The more he studied these ancient observations, the more convinced he became that something fundamental was missing from our understanding of how knowledge develops. Because knowledge is supposed to evolve gradually. Astronomers should start by noticing obvious patterns, the phases of the moon, the changing position of the sun, before moving on to subtler observations like planetary motion and eclipse prediction. You expect to find crude early attempts refined over generations into increasingly sophisticated understanding. But the Sumerian astronomical records showed no such evolution. The earliest observations they made were also the most accurate. Later copies made by Babylonians and Assyrians actually showed declining precision, as if each generation understood less about what they were copying than the one before. It was backwards. Instead of knowledge improving over time, it seemed to be degrading. Like a photograph of a photograph of a photograph, each copy losing resolution until the original image became unrecognizable. The mathematical sophistication troubled him most. The Sumerians used a base 60 number system that allowed for complex calculations involving fractions and angular measurements. This sexagesimal system was so elegant and practical that we still use it today. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. But why base 60? Most counting systems develop organically from human anatomy. Base 10 from our fingers, base 20 from fingers and toes. Base 60 seemed arbitrary until you realized its mathematical properties were perfectly suited for astronomical calculation and geometric measurement. It was as if the Sumerians had designed their mathematics specifically for astronomy, or as if their mathematics had been designed by minds that already understood what astronomical calculations would require. The star catalogues presented another puzzle. Sumerian astronomers didn't just observe celestial objects, they classified them. They distinguished between stars and planets, recognized that planets followed different paths across the sky, and grouped stars into constellations that we still use today. They understood that some stars never moved relative to each other, while others, the wandering stars or planets, traced complex paths against the stellar background. This kind of systematic observation required institutional memory spanning generations. Someone had to watch the same patch of sky night after night, year after year, decade after decade, carefully noting the smallest changes in position and brightness, and someone had to maintain those records, ensuring that the knowledge accumulated by one generation could be passed intact to the next. But where were the institutions that could support such long-term observation? The Sumerians had temples, but no universities. They had scribes, but no professional astronomers. They had cities, but no observatories. How do you maintain precision astronomical observations across centuries without the institutional infrastructure that precision requires? The silence outside Hunger's office felt different now, pregnant with the weight of questions that had no comfortable answers. In his desk drawer lay dozens of similar tablets, each one a witness to the same impossible fact. Humanity's oldest astronomical records were also its most accurate. He thought about the ancient observers themselves, standing on the flat rooftops of Sumerian cities, watching the eternal dance of lights in the desert sky. What had driven them to such patient observation? What had taught them which patterns mattered and which could be ignored? What had given them the confidence to build their entire civilization around astronomical calculations that required centuries to verify? Because that's what they had done. Sumerian agriculture depended on precise calendar calculations. Their religious festivals were timed to astronomical events. Their kings claimed legitimacy through celestial portents. Their entire culture was synchronized to the rhythm of the cosmos in a way that suggested deep, systematic understanding of how the sky worked. This wasn't casual stargazing. This was applied astronomy, put to work in service of civilization itself. And it was there from the beginning, fully formed as if someone had handed the Sumerians a complete astronomical manual and said, "Here, build your civilization around this." The myths supported this interpretation. Sumerian creation stories describe the Anunnaki teaching humanity to read the stars, to track the movements of celestial bodies, to calculate the passage of time itself. The god Marduk, was said to have established the constellations and set the calendar that governed earthly affairs. Most scholars interpreted these myths as symbolic explanations for cultural innovations. But sitting in his office, surrounded by tablets that whispered of knowledge too precise to have been achieved through trial and error, Hunger began to wonder if the Sumerians were describing something more literal. What if they weren't creating astronomical mythology? What if they were preserving astronomical instruction? Because the alternative, that the Sumerians achieved mathematical and observational precision rivaling modern astronomy through nothing but patience and naked eye observation, seemed to violate everything we knew about how knowledge develops. Knowledge builds gradually. It accumulates through countless small observations refined over generations into increasingly sophisticated understanding. But Sumerian astronomy appeared fully formed, like a gift that came with its own instruction manual. The implications were unsettling. If the Sumerians hadn't developed their astronomical knowledge through gradual observation, then someone must have taught them. Someone who already understood planetary motions, eclipse cycles, and stellar positions with mathematical precision. Someone who had already solved the problems of celestial mechanics that would challenge human civilization for thousands of years. And if that was true, if Sumerian astronomy was inherited rather than invented, then we had to ask, who were the teachers? Where did they learn to read the stars with such precision? And why does their knowledge feel like an echo of observations made by minds we can no longer imagine, under skies we can no longer see? Hunger closed his translation notes and sat in the growing darkness of his office, listening to the silence that fills spaces where important questions have no comfortable answers. Outside, Vienna's lights blurred the stars into irrelevance, hiding the same cosmic dance that had captivated Sumerian observers 5,000 years ago. But those ancient watchers had seen something we had lost. They had possessed knowledge we were still trying to reconstruct. And in their careful recordings, pressed into clay tablets and buried in desert sand, they had left us a map to mysteries we didn't yet know how to read. Because if their eyes couldn't see what they recorded with such precision, we had to ask, whose eyes did? And why does the thought of finding those original observers fill us with the same mixture of wonder and unease that must have gripped the first Sumerian astronomer as he realized he was mapping infinity with nothing but clay and starlight? You check the time. Digital numbers glowing back at you. 2:43 p.m. 2 hours, 43 minutes past noon. 60 seconds ticking by in each minute. 60 minutes accumulating in each hour. 360 degrees marking Earth's complete rotation that creates each day. Numbers so familiar they're invisible. So embedded in the architecture of modern life that questioning them feels absurd. Like asking why water is wet, or why gravity pulls down instead of up. But Dr. Eleanor Robson had been asking exactly those questions for 15 years, and the answers were making her deeply uncomfortable. Sitting in her office at Oxford's Oriental Institute, surrounded by photographs of Sumerian mathematical tablets that predated Pythagoras by 2 millennia, Robson felt the peculiar vertigo that comes from realizing something you've taken for granted your entire life has no logical explanation. Why 60 seconds in a minute? Why 60 minutes in an hour? Why 360 degrees in a circle? The answer wasn't mathematical convenience or natural observation or practical necessity. The answer was Sumer. A civilization that had been dust for 3,000 years was still governing how every human being on Earth measured time and space, and nobody could explain why their system worked so perfectly that we never bothered to replace it. Robson lifted a photograph of tablet YBC 7289 from her desk, a simple clay square covered with cuneiform calculations that had changed her understanding of mathematical history. The tablet showed a square with diagonal lines and numerical annotations that demonstrated the Babylonians knew the relationship we call the Pythagorean theorem 1,000 years before Pythagoras was born. But that wasn't what disturbed her about the tablet. What disturbed her was the precision of the calculations, all performed in base 60 mathematics with an elegance that suggested the system was already ancient when this particular scribe pressed his stylus into clay. Because mathematical systems are supposed to evolve, they start simple and grow more sophisticated as civilizations develop more complex needs. You expect to find primitive counting methods gradually refined into advanced calculation techniques. But Sumerian mathematics showed no such evolution. The earliest tablets contained the most sophisticated applications of base 60 arithmetic, including complex fractional calculations, tables of reciprocals, and even approximations of irrational numbers that wouldn't be formally defined until classical Greece. It was backwards, like finding the most advanced features in the first version of a software program, with later versions somehow less capable than their predecessors. The sexagesimal system itself defied explanation. Base 60 was mathematically elegant, divisible by 12 different numbers, making fractional calculations simple and precise. But why had the Sumerians chosen it? Most counting systems develop organically from human anatomy. Base 10 from counting on fingers. Base 20 from adding toes. Base 60 seemed arbitrary until you realized its mathematical properties were perfectly suited for astronomical calculation and geometric measurement. It was as if the Sumerians had designed their number system specifically for applications they hadn't yet discovered. Or as if the system had been designed by minds that already knew what those applications would require. Robson walked to her window and stared out at Oxford's ancient spires, thinking about the invisible presence of Sumerian mathematics in every aspect of modern life. GPS satellites calculated positions using coordinates measured in degrees and minutes. Computer processors synchronized operations using time measurements derived from base 60 navigation systems, guided ships and planes using angular calculations that trace back to cuneiform tablets pressed 5,000 years ago. The entire infrastructure of technological civilization was built on mathematical foundations laid by people who had never seen an airplane, never imagined a computer, never conceived of satellites orbiting Earth. Yet their numerical system worked flawlessly for applications they couldn't have anticipated. How do you accidentally create a mathematical framework perfect for technologies that won't exist for millennia? The academic community preferred not to ask such questions. The standard explanation was practical necessity. Base 60 was useful for trade and timekeeping, so it persisted through cultural transmission. But this explanation ignored the fundamental problem of origin. Where were the earlier, less sophisticated versions? Where were the competing numerical systems that should have existed during the developmental phase? Where was the archaeological evidence of mathematical experimentation and refinement? The Sumerian tablets showed no such developmental history. Base 60 appeared fully formed in the earliest mathematical texts, complete with advanced applications that suggested institutional knowledge spanning generations. It was like discovering that the first book ever written was already a masterpiece, with no evidence of anyone learning to write. Robson returned to her desk and opened a file containing her analysis of Sumerian mathematical education. The tablets revealed a sophisticated pedagogical system where students memorized vast tables of numerical relationships. Multiplication tables, reciprocal tables, square and cube tables, all calculated in base 60 with extraordinary precision. But these weren't rough approximations, gradually refined through use. These were exact values, calculated to multiple decimal places, using techniques that modern mathematicians recognized as sophisticated numerical analysis. The students weren't learning to discover mathematical relationships. They were learning to preserve them, which raised an unsettling question. Preserve them from what, or from whom? In the silence of her office, Robson found herself thinking about the persistence of inherited knowledge. How certain pieces of information could survive the collapse of civilizations, transmitted from generation to generation, not because they were understood, but because they worked. Like genetic information passing from parent to child, carrying instructions for processes the conscious mind never comprehended. The Sumerian creation myths described the Anunnaki teaching humanity, the ME, divine laws that governed everything from kingship to craftsmanship to the measurement of time itself. Modern scholars interpreted these myths as symbolic explanations for cultural innovation. But what if the Sumerians were describing something more literal? What if they were preserving the memory of actual instruction, not from gods, but from teachers, whose identity had been forgotten by the time the first mathematical tablets were written? Because the knowledge encoded in those tablets wasn't just advanced, it was specific, mathematical techniques perfectly suited for astronomical calculation, numerical systems optimized for complex engineering projects, geometric principles that wouldn't be formally rediscovered until the Renaissance. This wasn't the kind of practical knowledge you develop while learning to count sheep or measure grain. This was theoretical mathematics, the product of minds that had already solved problems most civilizations would struggle with for centuries. And yet, there it was, pressed into clay tablets by scribes who worked with the casual confidence of people following well-established protocols rather than inventing new ones. The implications were staggering. Every time someone checked their watch, they were using a time measurement system designed by unknown minds for unknown purposes. Every GPS calculation relied on angular measurements that trace back to mathematical principles embedded in cuneiform tablets. Every circular measurement, from the wheels on cars to the orbits of satellites, used a 360-degree system whose origins disappeared into prehistoric silence. Modern civilization was built on Sumerian mathematics, but nobody knew where Sumerian mathematics came from. Robson closed her files and sat in the growing darkness of her office, listening to the quiet tick of her wall clock, 60 beats per minute, marking time according to rules established before written history began. Outside, Oxford's bells chimed the hour in 12-tone sequences that echoed mathematical relationships first encoded in clay 5 millennia ago. The persistence was what troubled her most. Other ancient innovations had been improved, replaced, or forgotten. Egyptian hieroglyphs evolved into other writing systems. Roman architecture was superseded by new engineering techniques. Greek philosophy was refined by subsequent thinkers, but Sumerian mathematics persisted unchanged, as if it had achieved a perfection that couldn't be improved upon. As if it represented not human invention, but inheritance from a source that had already solved the fundamental problems of measurement and calculation. Which meant that every second ticking by on every clock in the world was marking time according to instructions written by minds we could no longer identify, for purposes we no longer remembered, following mathematical principles that arrived in human history, fully formed and perfect. And if that was true, if the numbers governing modern life were inherited rather than invented, then we had to ask, who designed the original system? What were they measuring so precisely? And why does their mathematics still work perfectly for applications they could never have imagined? Because somewhere in the silence before the first cuneiform tablet, someone had established the numerical rules that still governed how every human being experienced time and space. Someone had created a mathematical framework so robust that it could survive the collapse of empires, the forgetting of languages, and the transformation of human civilization from mud brick cities to spacefaring technology. Someone whose identity was now hidden behind 5,000 years of cultural transmission, but whose invisible presence could be felt every time you glanced at a clock and saw 60 seconds marking time according to their design. And why does that realization that we're still following mathematical instructions written by anonymous minds in prehistoric darkness feel less like discovery and more like remembering something we were never supposed to forget? The shadow falls exactly where it always has. Dr. Margaret Whitney stood at the base of the ziggurat of Ur, watching 4,000 years of sunlight paint the same geometric pattern across the desert sand that it had painted every winter solstice since the temple was built. The ancient bricks, crumbling and sun-bleached, still cast their shadow with the precision of a sundial, marking time according to astronomical calculations pressed into clay when mammoths still walked the earth. But this wasn't a sundial. It was something far more troubling. Whitney had spent 8 years studying Mesopotamian architecture, and the more she understood about ziggurat construction, the more convinced she became that these massive stepped pyramids weren't built for the living. They were built for memory itself. Architectural monuments designed to preserve knowledge that couldn't be trusted to human transmission alone. The question that haunted her was simple. Memory of what? Because ziggurats weren't accidents of ancient engineering. They were instruments built with mathematical precision and astronomical alignment that suggested their creators understood principles of celestial mechanics most civilizations wouldn't discover for millennia. Every measurement had meaning. Every angle served a purpose. Every alignment pointed toward knowledge we could no longer decipher. The ziggurat of Ur rose before her like a man-made mountain, its stepped sides climbing toward heaven in carefully calculated proportions. 70 feet tall in its current ruined state, it had originally soared over 100 feet into the Mesopotamian sky, its upper platform positioned to track the movements of Venus across the night sky. This particular temple had been built around 2100 BCE under King Ur-Nammu, but Whitney's archaeological survey suggested it followed blueprints far older than its construction date. The foundation measurements, the staircase orientations, the astronomical alignments, all of it matched patterns found in ziggurats across Sumer, as if every builder had access to the same master plan. A plan that seemed to encode knowledge nobody could explain. She walked around the temple's base, noting the precision of its cardinal alignment. The corners pointed almost exactly north, south, east, and west, an achievement that required sophisticated understanding of astronomy and geometry. The 3 staircases that climbed its sides faced specific celestial rising points, and the entire structure was positioned to serve as a massive observatory for tracking planetary motions. But observing what exactly? And for whom? In the growing heat of the Iraqi morning, Whitney found herself thinking about the peculiar consistency of ziggurat construction across time and space. From Uruk to Eridu to Nippur, every major Sumerian city had built one of these stepped pyramids. Different sizes, different kings, different centuries, but the same essential design. It wasn't variation on a theme. It was repetition of a pattern, preserved with the kind of obsessive fidelity that suggested the builders were following instructions they couldn't afford to misinterpret. The mathematical proportions were what troubled her most. Recent laser scanning had revealed that ziggurat dimensions followed precise geometric ratios, relationships between height, width, and volume that corresponded to astronomical cycles and mathematical constants that wouldn't be formally defined until classical Greece. These weren't arbitrary architectural choices. These were encoded formulas built into brick and mortar to ensure their preservation across centuries of cultural change. But formulas for what? Whitney climbed the ancient stairs, each step worn smooth by 4 millennia of feet, following the same ascending path. The climb was deliberate, designed to create specific sightlines and viewing angles that aligned with celestial events. Halfway up, she paused to examine a section of wall where clay tablets had been embedded directly into the brickwork. Astronomical observations literally built into the temple's structure. This was architecture as information storage, stone and clay serving as backup drives for knowledge that someone had been desperate to preserve. The view from the ziggurat's upper platform was breathtaking in its strategic clarity. The entire Mesopotamian plain stretched to the horizon, with sightlines carefully calculated to track the rising points of stars and planets. Ancient astronomers standing here would have had an unobstructed view of celestial events, with the temple itself serving as a massive instrument for measuring cosmic time. But the alignments were wrong for the current era. Using astronomical software, Whitney had calculated that the ziggurats' orientations made perfect sense for stellar positions as they appeared 4,000 years ago, but had since drifted due to the slow wobble of Earth's axis, a phenomenon called axial precession. The temple wasn't aligned to the present sky. It was aligned to an ancient memory of how the sky used to look, which raised an uncomfortable question. How had Sumerian builders known to account for precession, a celestial phenomenon so subtle it takes advanced mathematics and centuries of observation to detect? The silence on the platform felt deliberate, pregnant with the weight of questions that had no comfortable answers. Whitney pulled out her field notes and reviewed her analysis of ziggurat construction patterns. The evidence was undeniable. These temples followed design principles that seemed to encode sophisticated astronomical knowledge, mathematical relationships, and engineering techniques that appeared fully formed in the archaeological record. No experimental phases, no developmental stages, no evidence of trial and error. Just perfection, implemented with the confidence of builders who are following instructions rather than inventing techniques. The repetition across cities was what convinced her that ziggurats served a function beyond religious ritual. Each temple was essentially identical in its fundamental design, as if every Sumerian city had received the same set of blueprints and instructions for construction. The variations were cosmetic. Different sizes, different decorative elements, but the underlying pattern remained constant. It was like finding copies of the same book written in different languages, preserving identical information through different cultural expressions. But who had written the original book, and why had preservation been so important that entire civilizations dedicated their greatest architectural achievements to maintaining its instructions? The Sumerian creation myths provided clues that most scholars interpreted as symbolic. Stories of the Anunnaki teaching humanity to build temples that connected earth and heaven. Descriptions of divine knowledge encoded in sacred architecture. References to cosmic laws, the me, that governed everything from temple construction to royal succession. Whitney had always interpreted these myths as metaphorical explanations for cultural innovation, but standing on a platform built with astronomical precision that matched modern calculations, surrounded by evidence of mathematical knowledge that shouldn't have existed for centuries, she began to wonder if the Sumerians were describing something more literal. What if they weren't creating mythology about temple construction? What if they were preserving instruction about it? The silence pressed against her like a weight. Here on this ancient platform, she could feel the presence of minds that had solved problems her own civilization was still working to understand. Architects who had encoded knowledge into stone with such precision that their calculations still worked 4,000 years later. Engineers who had built monuments designed to preserve memory across spans of time that exceeded human comprehension, and yet their identity had been erased as completely as if they had never existed. The ziggurat beneath her feet was more than a temple. It was a message, written in the only language guaranteed to survive the collapse of civilizations: mathematics and stone. Its builders had understood that empires fall, languages die, and writing systems disappear. But geometric relationships endure, astronomical alignments persist, mathematical ratios survive. So they had built their knowledge into monuments designed to outlast memory itself. Whitney descended the ancient stairs as the sun climbed toward its zenith, casting shadows that fell according to calculations pressed into clay tablets, when humanity was supposedly just learning to write. Around the ziggurat's base, tourists photographed ruins they didn't understand, standing in the presence of encoded knowledge they couldn't read. The temple still functioned. Its alignment still tracked celestial events, Its proportions still embodied mathematical relationships that revealed their secrets to anyone with instruments precise enough to measure them. But the meaning had been lost. The instructions had been forgotten. The memory the ziggurat was built to preserve had succumbed to the same forgetting it was designed to prevent, which meant that somewhere in the silence between what these monuments were built to remember and what we had learned to forget, lay knowledge that had been considered important enough to encode in stone and preserve across millennia. Knowledge that we might still be standing on, walking past, photographing as curiosities, never realizing we were in the presence of libraries, written in a language of brick and astronomical alignment, waiting for minds sophisticated enough to read what their builders had been so desperate to preserve. And why does that possibility, that we might be surrounded by encoded knowledge we lack the wisdom to interpret, feel less like discovery and more like an inheritance we've misplaced, a memory we've been trying to recover without knowing what we lost? Professor Sarah Chen had translated hundreds of creation myths during her 20-year career in comparative religion, and they all followed the same basic pattern. Gods create the world through force or will, establish their dominance through displays of power, and demand worship from grateful humans who owe their existence to divine intervention. But sitting in her office at Yale's Department of Near Eastern Languages, staring at a fresh translation of the Sumerian text, Enki and the World Order, Chen felt the familiar vertigo that comes from encountering evidence that doesn't fit established patterns. Because the Sumerian gods weren't behaving like gods at all. They were behaving like consultants. The text described Enki, the god of wisdom and water, traveling from city to city in ancient Mesopotamia. But instead of demanding tribute or punishing disobedience, he was conducting what could only be described as an organizational restructuring. He assigned specific roles to each settlement. Who would manage irrigation systems? Who would oversee brick production? Who would handle livestock breeding? Who would maintain astronomical observations? This wasn't mythology. This was project management. Chen read through the passage again, noting the peculiar specificity of the divine instructions. Enki didn't just decree that canals should exist. He explained how they should be constructed. He detailed the proper depth for irrigation channels, the optimal spacing between water gates, the seasonal timing for flood management. The text included measurements, angles, and technical specifications that read less like religious poetry and more like an engineering manual. Why were the gods giving tutorials? The question had been troubling her for months as she worked through the broader corpus of Sumerian literature. Every major figure in their pantheon seemed to govern not just abstract concepts, but specific applied knowledge domains. Enki handled hydraulic engineering and urban planning. Ninmah managed medical procedures and public health protocols. Nabu oversaw record-keeping and data management. Utu regulated legal contracts and solar timekeeping. It was like discovering that the Greek pantheon consisted entirely of university professors, each one teaching specialized courses in different branches of human knowledge. But the most unsettling aspect wasn't the specificity of their roles, it was the consistency. These weren't evolving mythologies that changed with each telling. The Anunnaki maintained the same functions, the same areas of expertise, the same detailed knowledge across centuries of cultural transmission. From Sumer to Akkad to Babylon, their job descriptions remained remarkably stable, as if they were preserving something that couldn't be allowed to change. Chen pulled up her analysis of Enki and Ninmah, a creation myth that had always troubled her. The story described the two gods experimenting with early human creation, with Ninmah molding figures from clay while Enki provided feedback and modifications. When her initial attempts produced beings with physical limitations, the blind, the lame, the cognitively impaired, Enki didn't reject them. Instead, he carefully categorized each variation and assigned appropriate social roles based on functional capacity. Reading this as religious allegory, it seemed like a crude explanation for human diversity and social stratification. But reading it as encoded instruction, it began to resemble something else entirely. A medical classification system combined with early public health protocols. How do you care for individuals with different capabilities? How do you integrate them into productive social roles? How do you balance individual needs with community resources? These weren't theological questions. These were practical challenges that every civilization faced, encoded in narrative form that could survive the collapse of the institutions that originally developed the solutions. The preservation method was what convinced Chen that something extraordinary was happening in these texts. In a world without mass literacy, how do you maintain complex technical knowledge across generations? How do you ensure that critical information survives political upheavals, natural disasters, and cultural transformations? You embed it in stories that people will remember, repeat, and consider too sacred to alter. The mythological framework wasn't accidental. It was a deliberate preservation strategy. By transforming technical knowledge into divine instruction, the Sumerians had created a cultural immune system that protected essential information from the natural degradation that affects purely secular knowledge. Chen opened her files on astronomical mythology and found the same pattern repeated. Marduk, the Babylonian inheritor of Sumerian cosmic traditions, wasn't just king of the gods. He was described as the deity who established the constellations and set the calendar that governed earthly affairs. The texts attributed to him contained detailed astronomical observations, mathematical calculations for predicting eclipses, and precise seasonal calendars that agricultural communities used for planting and harvesting. Modern astronomers had verified many of these calculations and found them accurate to within fractions of a degree. But they were presented as divine decrees rather than scientific observations, wrapped in mythological language that made them easier to memorize and harder to forget. The implications were staggering. If the Anunnaki represented encoded knowledge rather than religious belief, then Sumerian civilization had developed the world's first distributed information storage system, a cultural database that could survive the destruction of physical libraries, the loss of literacy, even the collapse of the civilization that created it. But encoded memories of what? And why had preservation been considered so critical that entire mythological systems were designed around protecting technical information? Chen found herself thinking about the peculiar way these myths handled failure and experimentation. Unlike most creation stories, which described gods as omniscient and infallible, the Sumerian texts acknowledged trial and error, iterative improvement, and systematic problem-solving. Enki and Ninmah went through multiple attempts at human creation before achieving satisfactory results. Enki experimented with different approaches to canal construction before settling on optimal designs. This wasn't divine perfection. It was engineering methodology preserved in narrative form. The medical knowledge was perhaps the most sophisticated. Texts attributed to Ninmah contained detailed descriptions of herbal treatments, surgical procedures, and diagnostic techniques that wouldn't be formally systematized until much later in human history. But they were presented as divine healing wisdom rather than empirical medical knowledge. Chen had worked with medical historians to analyze some of these passages and found them remarkably accurate. Treatments described in mythological contexts often reflected sophisticated understanding of human anatomy, pharmacology, and disease progression. The success rate suggested extensive clinical experience rather than supernatural intervention. Yet this knowledge was attributed to gods who supposedly dispensed it as divine gift, rather than accumulated through human observation and experimentation. The legal and administrative knowledge was equally impressive. Nabu, the god of writing and record keeping, was associated with texts that contained detailed protocols for contract law, property rights, taxation systems, and judicial procedures. These weren't abstract moral principles. They were practical legal frameworks, sophisticated enough to govern complex urban societies. Modern legal scholars who studied these texts found them comparable to legal systems that wouldn't develop elsewhere for centuries, but they were preserved as divine commands rather than human innovation, embedded in religious contexts that ensured their careful transmission across generations. In the growing silence of her office, Chen found herself confronting a possibility that challenged everything she thought she knew about the relationship between religion and knowledge in ancient civilizations. What if the Sumerian pantheon wasn't a collection of supernatural beliefs, but a sophisticated information preservation system designed to maintain technical knowledge across potential civilizational disruptions? What if the Anunnaki were never meant to be worshipped as gods, but remembered as teachers whose lessons had been encoded in mythological form to ensure their survival? The preservation wasn't perfect. Over centuries, the technical content gradually degraded as the mythological wrapper became more important than the information it protected. Functions became personalities, systems became superstitions, instruction manuals became religious doctrines, but the core knowledge persisted, transmitted through ritual repetition and sacred narrative long after the original context had been forgotten, which raised the most troubling question of all. If these myths were designed as preservation systems, what knowledge was so important that it required such elaborate protection? What technical information was considered so essential that entire civilizations organized their religious practices around maintaining it? And why did the original teachers, whoever they were, believe this knowledge might be lost without extraordinary measures to preserve it? Chen closed her translation files and sat in the deepening darkness of her office, listening to the quiet hum of climate control systems maintaining optimal conditions for the preservation of ancient texts. Outside, New Haven bustled with the confident noise of modern civilization, unaware that some of its foundational knowledge might be encoded in stories it had learned to dismiss as primitive mythology. But those ancient narratives were still there, waiting in archives and libraries around the world. Patient repositories of encoded instruction, written by minds that understood something about the fragility of human knowledge and the necessity of protecting it against the forgetting that comes with time. Because if the Sumerian gods were really memories of human expertise preserved in mythological form, then we had to ask, what other knowledge might be hidden in stories we've learned to interpret as fiction? What other instruction manuals might be disguised as religious texts, waiting for minds sophisticated enough to recognize technical information wrapped in sacred narrative? And why does the thought that we might be surrounded by encoded wisdom we lack the insight to decode feel less like discovery and more like recognition? As if part of us has always known we were reading the stories wrong, missing lessons that someone considered too important to lose. Dr. Amanda Stelzer had been reading Sumerian literature for 12 years, and she thought she understood the difference between mythology and instruction manuals. Myths dealt in metaphors, symbols, and archetypal struggles between cosmic forces. Technical manuals provided precise measurements, sequential procedures, and cause-effect relationships. But sitting in her office at the University of Chicago's Oriental Institute, staring at a fresh translation of the creation epic Enki and Ninmah, Stelzer encountered a line that made both categories collapse into something she couldn't classify. The text described the god Enki molding the first human from clay. Standard creation mythology until line 47, which specified that the clay should be mixed with water in a ratio of 3 parts to 1 and kneaded until it holds its shape without cracking. That wasn't mythological language. That was pottery instruction. And once she started looking for it, Stelzer found technical specifications embedded throughout Sumerian literature, like hidden source code, in what appeared to be purely narrative texts. Temple construction myths included bricklaying sequences. Agricultural stories contained planting calendars. Divine pronouncements encoded legal procedures with the precision of constitutional amendments. These weren't metaphors behaving like measurements. These were measurements disguised as metaphors. The realization was profoundly unsettling. If Sumerian myths contained functional technical information, then everything archaeology had assumed about the relationship between religion and knowledge in ancient civilizations needed to be reconsidered. Because these texts weren't just preserving spiritual beliefs, they were operating as distributed technical libraries, encoding practical knowledge in narrative formats designed to survive the collapse of the institutions that created them. Stelzer pulled up her analysis of the Kesh Temple hymn, a religious text that had always struck her as oddly repetitive. The hymn praised the construction of a temple to the goddess Nintu. But instead of abstract veneration, it provided step-by-step construction procedures. Let the brick be carried. Let the foundation be laid. Let the walls rise 7 cubits. Let the reed door be hung in the sanctuary. Reading it as poetry, it seemed like ritualized repetition designed to create sacred atmosphere. Reading it as encoded instruction, it began to resemble a construction checklist that could guide actual building projects across generations. The measurements matched. Archaeological surveys of Sumerian temple foundations revealed construction techniques that corresponded exactly to the procedures described in religious hymns. The 7 cubits mentioned in mythological contexts turned out to be the standard height for temple platform foundations. The reed door specifications matched physical remains found at excavation sites. Someone had been following these mythological instructions with architectural precision. But the most troubling discovery was the ME, a concept that appeared throughout Sumerian literature without satisfactory translation. Scholars usually rendered it as divine decrees or cosmic laws. But Stelzer's analysis suggested something more specific and disturbing. The ME weren't abstract principles. They were discrete packets of technical knowledge. In the epic Enki and the World Order, the god Enki distributed me to different regions and cities, each one containing specific skill sets: metallurgy, irrigation, legal frameworks, astronomical observation, textile production, architectural techniques. The myth listed over 60 different ME, together comprising what could only be described as a complete civilizational operating system. And they weren't invented by humans. According to the texts, they were delivered. From where? By whom? The myths provided no clear answer. Only the insistence that these knowledge modules had been transmitted to humanity as gifts that enabled the transition from primitive survival to organized civilization. Stelzer stood and walked to her window, staring out at Chicago's skyline while her mind processed the implications. If the ME represented inherited technical knowledge, then Sumerian civilization hadn't developed its sophisticated capabilities through gradual innovation. It had received them as a package deal, complete with instructions encoded in mythological narratives designed to ensure their preservation across potential civilizational disruptions. The encoding mechanism was what convinced her that something extraordinary was happening in these texts. Modern memory experts use story-based techniques to retain complex information, building memory palaces where data could be stored in narrative frameworks that made abstract information easier to recall and harder to forget. The Sumerians appear to have developed the same technique on a civilizational scale, embedding technical knowledge in mythological narratives that could survive the loss of literacy, the collapse of institutions, even the forgetting of the original context, but embedded so cleverly that later generations would interpret instruction as inspiration, mistaking operational manuals for religious doctrine. Stelzer returned to her desk and opened a file containing her comparative analysis of Sumerian construction myths and archaeological evidence. The correspondence was undeniable. Mythological descriptions of divine building projects matched actual construction techniques with mathematical precision. The myth of Marduk establishing cosmic order included detailed specifications for astronomical observation that corresponded to the layout of Babylonian ziggurats. Stories about Enki's water management contained hydraulic engineering principles that matched the irrigation systems found throughout Mesopotamia. Divine pronouncements about social organization encoded legal frameworks sophisticated enough to govern complex urban societies. Someone had been using these myths as functional blueprints, following mythological instructions to build actual infrastructure. Which raised an even more disturbing question. If these narratives contained operational knowledge, what happened when the technical context was forgotten, but the stories persisted? The answer was all around her. Modern religious traditions preserved mythological narratives that might once have contained practical instruction, but the operational content had been lost while the symbolic wrapper survived. Stories that were once functional had become purely spiritual, their original purpose obscured by centuries of reinterpretation. How much technical knowledge had been lost because later generations forgot how to read instruction disguised as inspiration? In the growing silence of her office, Stelza found herself thinking about the peculiar way these myths handled process and sequence. Unlike most religious narratives which focused on moral lessons or cosmic truths, Sumerian myths paid obsessive attention to procedural details. What happened first? What materials were required? What conditions needed to be met? What results could be expected? They read less like spiritual allegories and more like technical documentation written in narrative form to make complex information memorable and transmissible across generations of oral tradition. The repetition pattern supported this interpretation. Sumerian myths often contained multiple versions of the same basic story, with slight variations that preserved different aspects of the encoded information, like backup copies of critical files, ensuring that even if one version was corrupted or lost, the essential data could be recovered from alternative sources, and the information was precise enough to function. Temple construction myths contained architectural specifications that worked when implemented. Agricultural stories included planting schedules that corresponded to optimal growing conditions. Legal narratives encoded judicial procedures that could govern actual communities. These weren't approximate symbolic representations. These were functional operational instructions that produce measurable results when followed correctly. Stelza closed her analysis files and sat in the deepening darkness of her office, listening to the quiet hum of climate control systems maintaining optimal conditions for the preservation of ancient texts. Around her, thousands of clay tablets and papyrus fragments preserved the written remains of civilizations that had risen and fallen across millennia. But how much of what we called mythology might actually be technology? Operational knowledge encoded in narrative form by minds that understood something about the fragility of human memory and the necessity of protecting critical information against the forgetting that comes with time. The Sumerian texts suggested that at least one ancient civilization had developed sophisticated techniques for embedding practical knowledge in mythological narratives, creating cultural preservation systems that could maintain technical information across potential civilizational collapses, which meant that other mythological traditions might contain similar encoded instruction, waiting for minds sophisticated enough to recognize technical information disguised as spiritual narrative. Because if stories could function as machines, preserving and transmitting operational knowledge across millennia through carefully structured narrative frameworks, then we had to ask, what other instruction manuals might be hiding in the myths we've learned to interpret as pure fiction? What other blueprints might be concealed in the stories we tell ourselves about gods and heroes? Waiting for archaeologists and linguists clever enough to recognize that some narratives were never meant to inspire belief, but to preserve the practical knowledge necessary for rebuilding civilization itself. And why does that possibility, that we might be surrounded by encoded wisdom we lack the insight to decode, feel less like discovery and more like recovery. As if part of us has always known we were reading the blueprints wrong, the story doesn't begin with creation. It begins with erasure. Dr. Michael Brennan had spent 15 years studying comparative flood mythologies, and the pattern never failed to disturb him. Across every continent, in cultures that had never contacted each other, the same narrative emerged with mechanical consistency. Humanity reaches a certain level of development, becomes troublesome to the gods, and gets wiped clean by water. One righteous survivor receives divine warning, builds a vessel, preserves life, and starts over on a simplified world. Not similar stories, identical structures. Sitting in his office at Harvard's Department of Folklore and Mythology, surrounded by translations from Mesopotamia, India, China, Mesoamerica, and North America, Brennan faced a question that academic archaeology preferred not to ask. How do isolated civilizations develop identical memories of global catastrophe? The conventional explanation was psychological universalism. Flood stories emerged independently because flooding was a common natural disaster that early societies needed to explain through mythology. But Brennan's analysis revealed something more troubling. These weren't explanatory myths about local flooding. They were preservation myths about civilizational reset. And they all pointed backward towards something that had been lost. The oldest version came from Sumer, pressed into clay tablets at least 4,000 years ago. The Eridu Genesis described a time when humanity had grown too numerous and too noisy for the gods to tolerate. So the divine council decided on erasure, a flood that would wash the world clean and allow for a fresh beginning. But the god Enki disagreed with this decision. He secretly warned a man named Ziusudra, providing detailed instructions for building a vessel that could preserve life through the coming catastrophe. Ziusudra followed these instructions precisely, loading his boat with animals and supplies before the waters came. After 7 days, the flood receded. Ziusudra opened a window, sent out birds to test for dry land, and made offerings to the gods who had both destroyed and preserved the world. In return, he was granted immortality, not as reward, but as insurance that someone would remember what had happened. The details were disturbingly specific, not the vague metaphors you'd expect from ancient mythology, but practical information about disaster preparation and survival, as if the story was designed to function as instruction rather than inspiration, and it had worked. The same narrative structure appeared in every subsequent flood tradition, from the Akkadian epic of Gilgamesh to the biblical account of Noah, each one preserving the essential elements: divine warning, righteous survivor, detailed instructions, catastrophic flood, mountain landing, bird reconnaissance, sacrificial offering, covenant renewal, like backup copies of the same critical file, distributed across cultures to ensure the information couldn't be lost again. Brennan opened his analysis of flood mythology distribution patterns, maps showing how the same story had appeared in civilizations separated by oceans and millennia. The Vedic tradition of Manu and the Great Deluge, Chinese legends of Yu the Great and the Cosmic Flood, Hopi stories of the world's destruction and renewal, Incan accounts of Viracocha and the cleansing waters. Each tradition claimed the story as their own origin myth, but the structural similarities suggested they were all remembering the same event, or the same trauma. Because the flood myths weren't just about water, they were about memory itself. In every version, the flood represented a break in continuity. The world before the flood was different, more advanced, more populated, more connected to divine knowledge. The world after was simpler, smaller, starting over with fragments of what had been lost. It was like reading multiple accounts of the same computer crash, each one describing the moment when everything had to be rebuilt from incomplete backups. The archaeological evidence supported this interpretation in unsettling ways. Throughout Mesopotamia, excavations revealed flood layers dating to approximately 2900 BCE, thick deposits of riverine silt that marked the violent end of early urban settlements at Shuruppak, Kish, and other Sumerian sites. These geological flood markers corresponded exactly to cultural disruption layers, where sophisticated early civilizations suddenly disappeared and were replaced by simpler societies. But the flooding hadn't been global. It had been localized to the Fertile Crescent where the world's first complex civilizations were developing, which meant the flood myths weren't describing a planetary catastrophe. They were preserving the memory of a cultural catastrophe that had felt like the end of the world to the people who experienced it. The question was, what had been lost in those waters? Brennan found himself thinking about the peculiar characteristics of post-flood civilizations. The Sumerians, who rebuilt after the Great Flooding, demonstrated knowledge and capabilities that seemed to exceed what should have been possible for survivors of catastrophic social collapse. Their mathematics, astronomy, engineering, and organizational systems showed sophistication that suggested continuity with advanced knowledge rather than gradual redevelopment from primitive conditions, as if they were reconstructing something they remembered imperfectly rather than inventing something new. The flood myths themselves contained clues about what had been preserved. In every version, the survivor wasn't chosen randomly. He was selected because he possessed specific knowledge or qualities that the gods wanted to maintain through the transition. Ziusudra was described as wise and righteous. Noah was called perfect in his generation. Manu was portrayed as a keeper of cosmic law. These weren't just moral exemplars. They were living libraries, chosen to carry forward essential information that couldn't be allowed to disappear completely. And what they preserved wasn't just biological diversity. According to the myths, they carried forward the me, those packets of civilizational knowledge that enabled the reconstruction of organized society after the waters receded. But reconstruction from what template? And why was the template apparently more sophisticated than what most post-flood civilizations managed to achieve? In the growing silence of his office, Brennan found himself confronting a possibility that challenged everything archaeology assumed about human development. What if the flood myths preserved the memory of an actual civilizational collapse so complete that it had reset human society to a pre-urban state, forcing survivors to rebuild from fragments of knowledge they no longer fully understood? What if Sumer wasn't humanity's first complex civilization, but its first attempt at reconstruction? The mythological evidence suggested exactly this scenario. The gods' regret after the flood, their promise never to destroy the world completely again, their decision to use more selective pressures in the future. These weren't abstract theological concepts. They were policy adjustments, learned responses to the recognition that total erasure was counterproductive. Even the mythological minds behind the flood had realized that complete destruction led to unacceptable knowledge loss, which meant they had experience with the consequences of civilizational collapse. They had tried total reset before and discovered it was too destructive to repeat. But who were they? The myths described gods making these decisions. But if the gods represented encoded memories of human knowledge systems, then they might have been the survivors of an even earlier collapse. Teachers and knowledge keepers who understood the fragility of complex societies and the necessity of preserving critical information through catastrophic transitions. The flood myths might be describing not one collapse, but a recurring pattern of civilizational rise and fall, with each cycle preserving fragments of knowledge from the previous iteration while losing other crucial elements to the chaos of reconstruction. And if that was true, then the flood story wasn't just ancient history, it was instruction about the present. Because modern civilization faced the same vulnerabilities that had destroyed its predecessors. Dependence on complex systems that most people didn't understand. Concentration of knowledge in institutions that could be disrupted. reliance on technologies that required specialized expertise to maintain. If the flood came again, whether as natural disaster, social collapse, or technological failure, how much of what we considered essential knowledge would survive? How many of our own survivors would be capable of rebuilding the systems we took for granted? And how much of what we called progress might actually be reconstruction, guided by half-remembered instructions encoded in stories we'd learned to interpret as primitive mythology rather than practical warning? Brennan closed his research files and sat in the deepening darkness of his office, listening to the quiet hum of climate control systems maintaining optimal conditions for the preservation of ancient texts. Outside, Cambridge hummed with the confident energy of modern academic civilization, secure in its assumption that knowledge once gained could never truly be lost. But the flood myths whispered otherwise. They preserved the memory of a time when advanced knowledge had been lost, when complex systems had collapsed, when human civilization had been forced to start over from fragments, and hope they contained enough information to rebuild something recognizable. And they all ended the same way, with a promise that it wouldn't happen again, coupled with the quiet understanding that promises made by human institutions were exactly as durable as the civilizations that made them, which left one final question echoing through the mythological silence. If every culture remembered the flood, who among us was prepared for the next one? And what knowledge were we preserving in forms that could survive the forgetting that comes when the waters of chaos rise again? The archaeological silence surrounding physical evidence raised its own questions. If beings possessing advanced technology had interacted with early civilizations, where were their tools, their structures, their biological remains? Several factors could account for this absence. Self-destructing technology designed to leave minimal traces, deliberate evidence removal during withdrawal, natural degradation over millennia, or systematic suppression of discoveries that would challenge fundamental assumptions about human history. For those seeking truth behind these patterns, attention should focus on genuine anomalies, genetic sequences that don't fit evolutionary models, archaeological sites displaying impossible precision, astronomical knowledge embedded in ancient structures, and persistent contemporary encounters echoing ancient themes. The spiral connecting these ancient centers of civilization points toward a culmination that has not yet arrived. Each previous cycle brought irreversible transformation, sometimes beneficial, sometimes catastrophic, but always fundamentally altering the trajectory of human development. The next iteration may determine whether humanity graduates from its role as subject to become something approaching a peer, or whether we remain forever locked in the position of creation or experiment. The fragments preserved across different cultures do not reveal complete truth, only enough to recognize that something operated beyond purely human agency. These narratives, in their remarkable consistency across isolated civilizations, feel less like independent inventions than scattered reflections of events too vast for any single culture to encompass fully. Whether these beings were gods, interdimensional travelers, advanced terrestrial species, or something for which our languages lack adequate terms, the impression they left endures. In myths, we continue retelling. In genetic codes we carry. In monuments we struggle to explain. And perhaps in the skies we watch with growing wonder and concern. To dismiss this pattern as coincidence requires ignoring a thread woven across millennia with remarkable precision. To accept it as historical memory means acknowledging that humanity's story has never been entirely its own to write. We may be characters in a narrative whose full scope we are only beginning to glimpse. Players in a drama whose other participants possess capabilities and perspectives that dwarf our current understanding. The final segment of this spiral remains unwritten, an open space between what has been and what is yet to come. Whether the next chapter brings renewed guidance, genuine partnership, or another reset as complete as the floods that cleansed earlier ages, the spiral's geometry suggests one inescapable truth. this story has not reached its conclusion. When the silence that has held for millennia finally breaks, whether through disclosure, contact, or catastrophe, humanity will face the most profound choice in our species' history. We will decide whether we remain echoes of our Maker's intentions, or whether we have developed the wisdom, courage, and unity necessary to stand as something approaching equals when the architects of our past step once again into the light. The pattern is carved in stone and written in stars, preserved in the deepest memories of our species. The spiral turns as it always has, as perhaps it always must. And somewhere in the space between earth and sky, in the gap between what we know and what we fear to discover, the next chapter waits to be written. The silence in a Harvard laboratory feels different at 3 a.m. Dr. Robert Hassan had been working with ancient tablets for 6 months when he made a discovery that would define the rest of his career. Not because of what he found, but because of what happened when he tried to talk about it. The tablet was catalogued under an unremarkable identifier sitting in storage since 1923. Hassan was tasked with creating digital records for uncategorized artifacts, routine work that rarely produced anything noteworthy. But when he began translating the cuneiform symbols, he found himself staring at something that challenged fundamental assumptions about ancient capabilities. The tablet contained precise calculations for planetary orbital periods that shouldn't have been possible with Bronze Age observation techniques. Not approximations or rough estimates, but mathematical values that matched modern measurements to within decimal points. Hassan double-checked his translation, consulted with senior colleagues, and ran the calculations through contemporary astronomical software. The ancient values were correct in ways that seemed to require instrumentation far beyond anything the historical records suggested these people possessed. When he submitted his preliminary findings to his department supervisor, the response was swift and discouraging. Interesting, but probably not worth pursuing for publication. These kinds of anomalous readings usually turned out to have mundane explanations. Hassan never published his research. The tablet was refiled in storage, and 6 months later his fellowship was not renewed. Sitting in his cramped office at a regional university 3 years later, Hassan had come to understand something about academic institutions that wasn't taught in graduate school. Silence was often policy disguised as methodology. The problem wasn't censorship in any dramatic sense. Nobody had forbidden him from studying anomalous tablets or pursuing unconventional interpretations. The restriction was subtler and more effective. Certain kinds of research simply weren't supported, funded, or rewarded within the existing institutional framework. Grants went to projects that promised to clarify established historical narratives, not challenge them. Publication opportunities existed for work that built incrementally on accepted theories, not research that suggested those theories might be fundamentally flawed. Academic positions were awarded to scholars who demonstrated expertise within recognized specializations, not those who crossed disciplinary boundaries or questioned basic assumptions. The result was a kind of intellectual ecosystem that selected against disruptive discoveries, ensuring that only research compatible with existing paradigms received the resources necessary for development and dissemination. Hassan opened his files on untranslated texts and felt the familiar frustration that had driven him from prestigious institutions to academic obscurity. Conservative estimates suggested that less than 20% of recovered tablets had been fully translated and published. The remainder sat in museum collections around the world, catalogued but unread, photographed but unstudied. Some contained routine administrative records, but others included references to unknown technologies, unfamiliar astronomical observations, mathematical techniques that didn't match established understanding of ancient capabilities. These anomalous texts weren't hidden or classified. They were simply ignored, left in storage, while scholarly attention focused on materials that fit comfortably within accepted historical frameworks. Hassan had encountered dozens of such tablets during his brief tenure at major institutions. clay fragments that described engineering techniques supposedly unknown to ancient civilizations, astronomical observations that required precision instruments, mathematical calculations that anticipated discoveries attributed to much later periods. None of it was studied seriously because none of it was fundable, publishable, or career-enhancing within the current academic environment. The institutional pressures were understandable from a practical perspective. Universities operated on limited budgets and competitive markets. Scholars needed to produce publishable research to maintain employment. Departments required grant funding to justify their existence. Museums had to balance scholarly investigation with public programming and donor relations. Revolutionary discoveries were risky investments that might not pay off. Incremental research was safer, more reliable, more likely to produce measurable outcomes within acceptable timeframes. But the cumulative effect was the creation of knowledge gaps that couldn't be explained by missing evidence. Some questions remained unanswered, not because relevant information didn't exist, but because investigating those questions was institutionally discouraged. Hassan found himself thinking about the broader implications of academic gatekeeping. How much potentially transformative research was never conducted because it fell outside established funding priorities? How many anomalous artifacts were sitting in storage because they didn't fit comfortable interpretations? How many patterns were invisible because they required interdisciplinary approaches that didn't align with departmental structures? The answers were unknowable, which was exactly the problem. The things that weren't studied remained unstudied, creating blind spots in human knowledge that persisted not because of evidential limitations, but because of institutional ones. The irony was profound. Modern scholarship had developed sophisticated techniques for recovering and interpreting ancient information. Archaeological methods could extract meaning from the smallest fragments. Linguistic analysis could decode dead languages with remarkable precision. Digital technology could preserve and cross-reference vast datasets with unprecedented efficiency. But all of these capabilities were constrained by human institutions that operated according to logic quite different from pure knowledge-seeking. Academic careers, funding priorities, publication pressures, and institutional politics shaped what questions were asked and what answers were permitted. The result was a kind of systematic forgetting that operated in real time. Not the accidental loss of information through fire or conquest, but the deliberate filtering of information through bureaucratic processes that determined what deserved attention and what could be safely ignored. Hassan closed his research files and walked to the small window of his office, looking out at the modest campus where he now taught introductory courses to undergraduates who would probably never hear about the anomalous tablets he'd discovered, the questions he'd wanted to pursue, or the institutional barriers that had prevented him from doing so. In the growing silence of the afternoon, he found himself wondering how many other researchers had encountered similar evidence and faced similar choices. How many had decided that career stability was more important than disruptive discovery? How many had learned to ask only the questions that academia was prepared to answer? The academic world prided itself on rational inquiry and evidence-based conclusions, but rationality operated within institutional contexts that were far from neutral. What counted as valid evidence, legitimate methodology, and acceptable interpretation was determined by human communities with their own interests, assumptions, and blind spots, which meant that even in an age of unprecedented access to information, certain kinds of knowledge could become effectively invisible, not because they were false or unimportant, but because they were inconvenient to the institutional structures responsible for validating and disseminating human understanding. The silence wasn't the absence of evidence. It was the presence of choice, the collective decision to look in some directions and not others, to ask some questions and not others, to preserve some possibilities and quietly abandon others. And perhaps that was the most troubling realization of all. The forgetting that had erased so much ancient knowledge wasn't just a historical process that had ended with the development of modern scholarship. It was an ongoing dynamic that continued to shape what contemporary civilization chose to remember and what it chose to forget. Because in the end, the greatest threat to human knowledge might not be fire or conquest or natural disaster, but the simple bureaucratic decision to file certain questions under not worth pursuing and leave them there, gathering dust in the archives of institutional indifference. And why does that possibility that we might be living through our own age of systematic forgetting, losing understanding not through catastrophe, but through administrative neglect, feel less like academic criticism and more like civilizational warning about the fragility of curiosity itself? Dr. Margaret Chen had been studying civilizational development for 28 years, and she thought she understood how human societies evolved. Small groups learned to farm. Farming villages grew into towns. Towns developed into cities. Cities created writing systems, legal codes, and religious institutions. It was a logical progression that explained the rise of every major civilization she had studied. Except one. Standing in the reading room of the Oriental Institute at the University of Chicago, surrounded by tablets, charts, and translation notes that represented decades of research into ancient Near Eastern civilization, Chen felt the weight of accumulated evidence that pointed toward a conclusion she couldn't quite bring herself to accept. These people hadn't followed the rules. They hadn't climbed slowly from primitive beginnings to sophisticated achievement. They had appeared in the historical record with capabilities that should have taken centuries to develop, knowledge that should have required generations to accumulate, and institutional systems that should have emerged gradually through trial and error. Instead, they had arrived fully formed. Chen walked to the display case containing photographs of the earliest tablets dated to around 3200 BCE. These weren't crude experiments in communication. They were polished documents written in standardized script, following established grammatical rules, recording complex transactions using sophisticated numerical systems. The earliest examples of this writing system showed no learning curve. She moved to the astronomical charts that mapped ancient knowledge of planetary motion. The calculations were precise enough to predict eclipses, track celestial cycles, and create calendars that accounted for complex relationships between lunar months and solar years. The earliest examples of this astronomy demonstrated accuracy that wouldn't be matched for millennia. The mathematical tablets told the same story. These ancient mathematicians had developed a base 60 system, elegant enough to handle complex fractions, advanced enough to calculate square roots, and practical enough that modern civilization still used it to measure time and space. The earliest examples of this mathematics contained techniques that modern students struggled to master. In every domain Chen examined, the pattern repeated. These people hadn't gradually developed their capabilities. They had implemented them as if they were working from instructions, rather than experimenting with possibilities. The urban planning was the most unsettling evidence. Ancient cities usually showed archaeological layers that revealed gradual growth, small settlements expanding into larger ones, early buildings replaced by more sophisticated structures. Infrastructure added piece by piece as populations grew and needs became more complex. But these cities showed different patterns. They appeared to have been planned from the beginning, with sophisticated drainage systems, organized districts, and monumental architecture that suggested their builders understood urban engineering principles from the moment construction began. These weren't cities that had grown, they were cities that had been built. Chen returned to her desk and opened her comparative analysis of civilizational development timelines. Every other ancient society showed clear developmental phases. Egypt's pre-dynastic period preceded the unified kingdom by centuries. China's Neolithic cultures evolved gradually into historical dynasties. Mesopotamian societies before this particular culture demonstrated slow progression from scattered villages to larger settlements. Only this one civilization broke the pattern appearing suddenly with capabilities that exceeded those of societies that had supposedly learned from their example. The technological sophistication was undeniable. Their metallurgists had developed smelting techniques and alloy recipes that required understanding of chemistry and physics. Their medical practitioners had created surgical procedures and pharmaceutical preparations that demonstrated systematic knowledge of human anatomy. Their engineers had built irrigation systems and architectural monuments that required mathematical precision and structural understanding. All of it emerged simultaneously, as if someone had activated multiple knowledge systems at once, rather than developing them sequentially through gradual innovation. But perhaps the most telling evidence was what hadn't survived in the archaeological record. Every other ancient civilization left traces of its developmental phase, crude early tools that evolved into sophisticated instruments, simple buildings that grew into complex architecture, basic art that developed into refined expression. This civilization left no such traces. Their earliest artifacts were already sophisticated. Their first buildings were already engineered. Their initial art was already symbolic and complex. It was as if they had skipped the learning phase entirely. Chen found herself thinking about the implications of what she was seeing. If this civilization hadn't developed gradually, then either they were unprecedented geniuses who had somehow invented complex society from scratch, or they had inherited their knowledge from sources that were no longer visible in the archaeological record. The first possibility seemed to violate everything known about human cognitive development and social evolution. The second possibility suggested that much of what archaeology assumed about the origins of civilization was wrong. But there was a third possibility that Chen found even more unsettling, that this civilization represented not innovation, but recovery, that their remarkable capabilities weren't the result of sudden inspiration, but of systematic preservation of knowledge that had been developed elsewhere, earlier, by minds whose identity had been lost to time. The textual evidence supported this interpretation. Their creation stories consistently described civilization as something delivered rather than discovered. Their pantheon was portrayed as teachers who provided pre-existing knowledge rather than gods who inspired human innovation. Their cosmic principles were described as things that were recovered rather than invented. If these texts preserved cultural memory rather than pure fantasy, they suggested that this civilization had been designed to maintain knowledge systems that predated its own existence. Chen walked to the window and stared out at the Chicago skyline, thinking about the broader implications of what this evidence suggested about human history. If one ancient civilization had achieved remarkable sophistication and then disappeared so completely that only fragmentary knowledge survived in later reconstructions, how many others might have followed the same pattern? How much human history might be missing from the archaeological record because it had been systematically erased, accidentally lost, or deliberately hidden? The silence in the archive felt different now, pregnant with the weight of questions that challenged fundamental assumptions about human development. If this represented recovery rather than innovation, then the entire timeline of civilizational progress needed to be reconsidered, which meant that modern civilization might not represent the pinnacle of human achievement, but simply the latest attempt to recover capabilities that had been lost and regained multiple times throughout history. The thought was both humbling and terrifying. Humbling because it suggested that human potential was far greater than contemporary achievements indicated. Terrifying because it implied that even remarkable civilizations could disappear so completely that later societies would have no memory of their existence. And if that was true, then the most important question wasn't how these ancient people had achieved so much so quickly, but how much knowledge modern civilization might be forgetting while congratulating itself on its unprecedented sophistication. Chen closed her research files and sat in the growing darkness of the reading room, surrounded by evidence of human capabilities that exceeded what should have been possible for their historical context. Around her, Thousands of tablets preserved fragments of knowledge systems that had somehow appeared fully formed in the archaeological record, flourished for centuries, and then gradually faded as later civilizations lost the ability to maintain what they had inherited. It was a pattern that felt less like ancient history and more like contemporary warning. Because if these ancient people had been rebuilding from incomplete memories of something even greater that had been lost, we had to ask, what were we rebuilding from? And what were we losing while we focused on what we thought we were discovering? And why does that possibility that we might be living through our own cycle of recovery and loss, preserving fragments while forgetting foundations, feel less like academic speculation and more like recognition of something we had always suspected but never dared to acknowledge about the true relationship between human memory and human potential? The clay tablets sit in climate-controlled silence, waiting in museums across the world, in private collections, in storage rooms that haven't been opened in decades. Thousands of them, maybe tens of thousands, each one pressed with symbols that once carried meaning across the ancient world. Each one a fragment of something larger that we've learned to call mythology instead of memory. But what if we've been reading the story backward? What if civilization isn't a mountain we're climbing, but a circle we keep entering? What if progress isn't linear ascent, but cyclical recovery? What if every time we think we're discovering something new, we're actually remembering something old? These ancient people appeared in history like a door opening in a wall we didn't know was there. Cities without prehistory, writing without evolution, mathematics without learning curves, knowledge systems so sophisticated they governed our world 5,000 years later, yet so mysterious we couldn't explain where they came from. They called their teachers by names that translated as those who came down from heaven. We call that mythology. But maybe mythology is just history that survived the flood, encoded in stories because stone tablets couldn't preserve what really mattered. The understanding that knowledge itself is fragile, that civilizations rise and fall, that memory can be deliberately erased. And maybe that's what these ancient people really left us. Not just the first writing, the first cities, the first laws, but the first warning, encoded in every myth about floods that washed the world clean, hidden in every temple built to preserve what couldn't be allowed to disappear, whispered in every story about teachers who once instructed humanity and then left. Because if you wanted to hide the most important truth in human history, where would you put it? In a library that could burn? In a language that could die? In institutions that could fall? Or would you embed it so deeply in the foundations of civilization itself that even when everything else collapsed, even when the libraries burned and the languages died and the institutions crumbled, the truth would still be there, waiting in the shadows of every story we tell ourselves about where we came from? These ancient people knew something we've forgotten, that forgetting isn't accidental. It's systematic. It's the natural consequence of believing that what we have can never be lost, that what we know can never be forgotten, that what we've built can never fall. But everything falls, everything burns, everything floods. Except the stories we tell in the dark when we think no one is listening. And maybe that's where the real truth is hiding. Not in the tablets we've translated, but in the silence between the words. Not in the myths we've decoded, but in the memory they're still trying to preserve. Because somewhere in that silence, something is waiting to be remembered. Something that knows we've been here before. Something that's watching us forget. The pattern is carved in stone and written in stars, preserved in the deepest memories of our species. And somewhere in the space between earth and sky, in the gap between what we know and what we fear to discover, the next chapter of this ancient story waits to be written. The implications extend far beyond academic curiosity. If we're living in humanity's second act, what destroyed the first? And more unsettling still, what makes us think we're immune to the same forces that erased our predecessors so completely that we barely remember they existed. Modern science offers its own uncomfortable parallels to these ancient mysteries. In 1973, Francis Crick, the Nobel Prize winner who helped decode DNA, proposed something that should have ended his career. He suggested that life on Earth might not have originated here naturally. The complexity of genetic code, he argued, resembled engineered programming more than the products of random chemical evolution. Crick wasn't engaging in science fiction. He was observing that the mathematical precision of DNA looked suspiciously like technology rather than accident, like instructions written by minds that understood biological systems at levels we're only beginning to grasp. The same uncomfortable precision appears in human genetics itself. Our chromosome structure differs from every other primate in a way that defies gradual evolutionary change. We carry genetic sequences that seem to have no clear ancestry, fragments of code that geneticists call junk DNA, because they can't determine its function. But what if it's not junk at all? What if it's dormant programming, waiting for conditions we haven't yet learned to recognize? Recent archaeological discoveries have only deepened these questions. At Göbekli Tepe in Turkey, massive stone circles emerge from the earth that predate agriculture itself. Carved pillars weighing 20 tons, arranged with astronomical precision, created by people who supposedly lived in small nomadic bands focused entirely on survival. The site was deliberately buried around 8000 BCE, carefully covered with tons of stone and debris to preserve it rather than destroy it. Someone wanted to ensure these monuments would survive, even if the knowledge of their creators didn't. Standing among those ancient pillars today, you can feel the weight of questions that stretch back 11,000 years. These weren't primitive people stumbling towards civilization. These were minds capable of sophisticated planning, advanced engineering, and symbolic thinking that rivals anything we've achieved. But they left no written records, no cities, no evidence of the infrastructure that such massive projects should have required. They appeared, built monuments that still challenge our understanding, then vanished back into the landscape as if they had never existed. The pattern repeats across the globe. Easter Island's Moai statues, carved from volcanic rock and somehow transported across the island without wheels or large animals. The precision-cut stones of Pumapunku in Bolivia, fitted together so perfectly that you can't slip a knife blade between them. The massive trilithon blocks at Baalbek in Lebanon, each weighing over 1,000 tons, moved and positioned with techniques that would challenge modern heavy machinery. Every culture that built these monuments claimed they inherited the knowledge from teachers who came before, teachers who descended from the sky, shared advanced wisdom, then departed with promises to return. We call these stories mythology because accepting them as history would require rewriting everything we think we know about human development. But what if the myths are trying to tell us something we're not ready to hear? Modern astronomy has revealed the existence of thousands of potentially habitable planets throughout our galaxy. The mathematical probability of Earth being unique becomes vanishingly small as we discover the vast scale of the universe. If advanced life exists elsewhere, contact with developing civilizations wouldn't be unprecedented, it would be inevitable. The question isn't whether such contact could have occurred. The question is whether we would recognize the evidence if it existed. In laboratories around the world, geneticists are discovering that human DNA contains sequences that don't match the evolutionary patterns we see in other species. Anthropologists are finding archaeological sites that demonstrate capabilities far beyond what their supposed time periods should have allowed. Linguists are uncovering linguistic structures in ancient languages that suggest knowledge systems more sophisticated than we previously imagined. Each discovery in isolation might be explained away, but together they form a pattern that challenges our most fundamental assumptions about human origins and development. The ancient texts themselves provide the most direct testimony. Across different continents and cultures, separated by thousands of years, the same story appears with remarkable consistency. Beings from the sky who taught humanity the arts of civilization. not metaphorically, but literally, not as inspiration, but as instruction. The Mesopotamian Anunnaki, who gave humans knowledge of agriculture, astronomy, and law. The Egyptian Neteru, who established the foundations of pharaonic civilization. The Vedic Devas, who shared advanced technologies and cosmic wisdom. The Hebrew Watchers, who descended from heaven to interact with early humanity. Different names, different cultures, but the same core narrative. Advanced beings who intervened in human development, transferred sophisticated knowledge, then withdrew or were forced to leave. These accounts contain technical details that their supposed authors shouldn't have understood. Descriptions of genetic manipulation that align with modern biotechnology. References to astronomical phenomena that require advanced observation techniques. Mathematical concepts that wouldn't be formally developed for thousands of years. Either these are remarkable coincidences, or they preserve memories of actual events that were later mythologized to ensure their survival across cultural upheavals and civilizational collapses. The flood narratives that appear in every ancient tradition provide another piece of this puzzle. Not just local stories about seasonal flooding, but global accounts of worldwide catastrophe that reset human civilization. The biblical Noah, the Mesopotamian Ziusudra, the Hindu Manu, the Greek Deucalion. All describe the same event: advanced pre-flood civilizations destroyed by water, with only fragments of knowledge preserved by chosen survivors. Geological evidence supports at least some version of these accounts. The end of the last ice age involved massive climatic changes that could have destroyed coastal civilizations worldwide. Rising sea levels, catastrophic flooding, and dramatic environmental shifts that would have forced mass migrations and cultural disruptions. If advanced civilizations existed before these changes, their remains would now lie beneath hundreds of feet of water on continental shelves around the world, effectively inaccessible to conventional archaeology, but perhaps not entirely lost to human memory. The survivors of such catastrophes would have faced an impossible task: rebuilding complex societies from incomplete knowledge while struggling with immediate survival needs. Much would be lost in the process. Techniques would be forgotten. Technologies would degrade. Advanced understanding would be preserved only in fragments, passed down through oral traditions that gradually transformed technical instruction into mythological narrative. This process explains the peculiar characteristics of early post-flood civilizations. They possessed knowledge that seemed too advanced for their supposed developmental stage, but applied it incompletely, as if working from damaged blueprints or half-remembered instruction. The Sumerians, with their sophisticated mathematics and astronomy, but no clear explanation for how they acquired such knowledge. The Egyptians, with their precise engineering and advanced medicine, but myths that attributed these capabilities to divine instruction rather than human innovation. If these civilizations were indeed reconstructing lost knowledge rather than developing it from scratch, their achievements become less mysterious and more tragic. They weren't primitive peoples making remarkable leaps forward. They were survivors of a greater catastrophe, struggling to preserve whatever they could remember of a more advanced past. The implications of this perspective extend far beyond historical curiosity. If human civilization has experienced cycles of rise and collapse before, we need to understand what forces drove those cycles and whether they might recur. Modern civilization faces vulnerabilities that could trigger similar collapses: climate change, resource depletion, technological dependence, social fragmentation. Our complex systems require specialized knowledge that most people don't possess. Our infrastructure depends on technologies that few truly understand. Our survival depends on institutions that could be disrupted by relatively minor catastrophes. If the patterns preserved in ancient myths reflect actual historical cycles, then we're not just studying the past, we're looking at potential futures, examining what happens when civilizations become too complex to maintain, too specialized to survive disruption, too confident in their permanence to prepare for collapse. The ancient texts don't just describe what happened, they provide warnings about what could happen again. Instructions for preserving essential knowledge through catastrophic transitions. Guidelines for rebuilding when complex systems fail and specialized expertise is lost. But these warnings are encoded in stories we've learned to dismiss as primitive mythology, hidden in narratives we interpret as fantasy rather than practical instruction, buried beneath layers of cultural reinterpretation that have obscured their original purpose. Recovering these messages requires more than archaeological investigation or linguistic analysis. It requires recognizing that our ancestors might have been far more sophisticated than we assume, far more experienced with civilizational collapse than we're comfortable acknowledging, and far more concerned with preserving knowledge for future generations than we've given them credit for. Because if the ancient accounts preserve memories of actual events rather than invented stories, then human history contains chapters we've forgotten how to read. Entire civilizations that rose and fell before our current historical timeline begins. Knowledge systems that achieved levels of sophistication we're only now beginning to rediscover, and warnings about patterns that might be preparing to repeat themselves in our own time. The question that emerges from this investigation isn't just what happened in the distant past. It's what's happening now. Are we living through another cycle in this ancient pattern? Have the forces that shaped human development throughout history withdrawn completely? Or do they remain active in forms we haven't learned to recognize? Recent decades have brought phenomena that echo the ancient accounts with unsettling clarity. Official government acknowledgement of aerial objects displaying capabilities far beyond current human technology. Genetic discoveries that challenge conventional models of human evolution. Archaeological findings that push back the timeline of sophisticated human civilization, and a growing sense that our species' story might be far more complex and far less autonomous than we've been taught to believe. The ancient texts speak of teachers who promise to return, watchers who continue to observe human development, cycles that repeat according to cosmic schedules we don't fully understand. If these accounts preserve actual memories rather than invented myths, then the story they tell hasn't reached its conclusion. We might be living in the quiet interval between chapters, the pause between one phase of guided development and the next. The calm before contact resumes in forms we can no longer dismiss or explain away. And if that's true, then everything we think we know about human independence, about our species' natural development, about our place in the cosmos, might be about to change in ways we can barely imagine. The ancient people who built those impossible monuments, who possessed that inexplicable knowledge, who preserved those persistent stories about teachers from the sky, might not have been describing their past at all. They might have been describing our future. The silence that follows this realization isn't empty. It's pregnant with possibility, heavy with questions that demand answers we might not be prepared to receive. Because if human civilization truly represents recovery rather than discovery, if our greatest achievements are echoes of something far older and more sophisticated than we've dared to imagine, then we're forced to confront the most unsettling question of all. What are we recovering toward? The evidence scattered across archaeological sites worldwide doesn't just challenge our timeline of human development. It suggests that timeline itself might be fundamentally backwards. We've been measuring human progress from what we assumed was the beginning, but every anomalous artifact, every impossible precision cut stone, every astronomical alignment that shouldn't exist whispers the same disturbing truth. We weren't climbing towards civilization, we were climbing back to it. This perspective transforms everything we thought we understood about human potential. The mathematical precision of ancient monuments isn't remarkable because Bronze Age people achieved it despite their limitations. It's remarkable because it represents fragments of knowledge that once existed in complete form, preserved by civilizations that understood their own fragility and took extraordinary measures to ensure essential information would survive whatever catastrophe they saw coming. The megalithic structures scattered across every continent suddenly make sense not as primitive attempts at grandeur, but as sophisticated information storage systems. Libraries written in stone because stone outlasts paper, outlasts languages, outlasts entire cultures. The builders weren't trying to impress future generations. They were trying to teach them, using the only medium guaranteed to survive the collapse of everything else. But teaching them what exactly? Modern archaeology has been asking the wrong questions. Instead of wondering how ancient peoples achieved such impossible precision, we should be asking what they were trying so desperately to preserve. Instead of marveling at their mathematical sophistication, we should be decoding what those mathematical relationships were designed to communicate across millennia. Because the pattern emerging from this evidence suggests that human civilization has been here before, not once, but multiple times. Each cycle reaching levels of sophistication that we're only now beginning to approach, each ending in catastrophe so complete that the survivors could preserve only fragments, forced to rebuild from incomplete instructions, while the full scope of what was lost faded into mythology. The flood narratives that appear in every ancient tradition aren't just shared memories of local disasters. They're cultural scars left by civilizational collapse so traumatic that every surviving culture felt compelled to preserve the memory, to ensure that future generations would understand what they were rebuilding from and why that rebuilding was necessary. These stories don't describe the punishment of primitive peoples by angry gods. They describe the systematic reset of advanced civilizations that had somehow exceeded safe parameters, that had developed capabilities their controllers deemed too dangerous to maintain. The survivors weren't chosen for their moral righteousness. They were chosen for their ability to preserve essential knowledge while forgetting dangerous applications. This interpretation explains the peculiar characteristics of early post-flood civilizations. They possessed sophisticated knowledge, but applied it cautiously, as if working from incomplete manuals with crucial pages missing. They built impressive monuments, but included obsessive redundancy, as if terrified of losing any fragment of information they'd managed to preserve. They encoded essential knowledge in multiple formats: stone, mathematics, mythology, astronomy, ensuring that even if several preservation methods failed, something would survive. The Sumerian obsession with astronomical precision wasn't primitive star worship. It was a sophisticated attempt to maintain calendar systems essential for agricultural timing, navigation, and the prediction of celestial events that governed everything from religious festivals to political decisions. Their base 60 mathematics wasn't an arbitrary counting system. It was a carefully designed framework, optimized for the kinds of calculations that complex civilizations require to function. These weren't innovations. They were preservation protocols. But preservation of what? And why had preservation become so urgent that entire civilizations organized themselves around maintaining knowledge they clearly didn't fully understand? The answer might lie in the persistent accounts of teachers who came from beyond Earth. Not metaphorical divine inspiration, but actual instruction from beings whose capabilities exceeded anything terrestrial civilizations could develop independently. Beings who had guided human development through previous cycles, and who withdrew or were forced to withdraw when their interventions produced unintended consequences. Modern science has revealed that our galaxy contains billions of potentially habitable worlds, many far older than Earth. The mathematical probability that intelligence evolved only here approaches zero. If advanced civilizations exist elsewhere in the cosmos, contact with developing worlds wouldn't be unprecedented. It would be routine. The question isn't whether such contact could have occurred. The question is what happened to end it. and whether whatever ended it might be preparing to end again. Recent decades have brought phenomena that echo these ancient patterns with uncomfortable precision. Aerial objects displaying impossible flight characteristics, genetic anomalies that don't fit standard evolutionary models, archaeological discoveries that push sophisticated human civilization further back in time with each excavation, and a growing awareness that our species' rapid technological advancement might not be as independent as we've assumed. The ancient texts speak of cycles, of periods when contact is active followed by intervals of withdrawal, of knowledge being shared and then restricted when its applications exceed safe boundaries, of civilizations being allowed to develop to certain thresholds before facing reset conditions that determine whether they advance to the next level or begin again from simplified foundations. If these accounts preserve actual memories rather than invented stories, then we might be approaching the end of another cycle. The signs described in ancient texts as preceding major transitions are manifesting in our time with increasing frequency. Rapid technological advancement, growing awareness of non-human intelligence, disclosure of previously hidden information, and choices that will determine whether humanity advances to genuine independence or faces another reset. The implications extend far beyond historical curiosity. If we're living in a recurring pattern rather than a unique ascent, then the decisions we make in coming decades might determine not just our immediate future, but whether our species finally graduates from guided development or continues cycling through the same basic progression indefinitely. The ancient builders who encoded warnings in stone, who preserved essential knowledge in mythological form, who built monuments designed to outlast civilizational collapse, weren't just talking to their immediate descendants, they were talking to us. Across thousands of years, they were trying to communicate that this moment, our moment, would come again, that we would face the same choices they faced, that our responses would determine whether we finally break free from the pattern or repeat it once more. The silence surrounding these possibilities in academic and political circles isn't accidental. Acknowledging that human civilization might be guided rather than independent would require fundamental revision of every assumption about our species' nature, our place in the cosmos, and our relationship to intelligence beyond Earth. Such acknowledgement would transform not just historical understanding, but contemporary policy, religious belief, and individual identity. But the evidence continues accumulating. Each new archaeological discovery, each genetic anomaly, each officially acknowledged encounter with non-human technology. Each revelation that previously classified information about unusual phenomena has been systematically concealed from public awareness. The pattern is becoming too obvious to ignore, too consistent to dismiss as coincidence, too important to suppress indefinitely. We stand at a threshold that previous human civilizations have approached multiple times throughout history. The threshold between guided development and genuine independence, between cycling through predetermined patterns and breaking free into authentic autonomy, between remaining perpetual students of more advanced minds and becoming true peers in a cosmic community we're only beginning to glimpse. The ancient texts that survived civilizational collapse weren't just preserving historical information. They were providing instruction for this moment, guidelines for recognizing when the cycle approaches completion, warning signs that indicate whether humanity is ready for the next phase or needs to begin again from simplified foundations. The choice isn't being made for us this time. It's being made by us. Our responses to disclosure, to contact, to the revelation that we've never been as alone or as independent as we believed will determine which direction the pattern takes. The ancient people who built impossible monuments, who possessed inexplicable knowledge, who preserved persistent stories about teachers from the sky, understood something we're only now beginning to grasp. They knew this moment would come. They knew we would need to choose. They knew the consequences of choosing wrongly and they left us everything we needed to choose correctly, hidden in plain sight, waiting for minds sophisticated enough to recognize instruction disguised as history, wisdom disguised as mythology, and warnings disguised as ancient mysteries. The silence is breaking, the pattern is completing, the choice is ours. What happens next depends entirely on whether we've learned from the lessons our predecessors tried so desperately to preserve, or whether we'll repeat the same mistakes that have reset human civilization multiple times throughout its hidden history. But there's something else hidden in the shadows of this investigation that we haven't discussed yet, something that makes the institutional silence even more troubling than simple academic gatekeeping or bureaucratic indifference. Because while researchers like Dr. Hassan face career consequences for pursuing uncomfortable questions, others have encountered something far more direct. In 2019, a team of marine archaeologists working off the coast of Japan made a discovery that should have revolutionized our understanding of human civilization. Sonar imaging revealed what appeared to be massive stone structures on the seafloor, geometric formations that bore no resemblance to natural geology. The initial survey data suggested construction techniques and architectural sophistication that predated known civilizations by thousands of years. Within 6 months, funding for the project was quietly terminated. The lead researcher received an unexpected job offer at a private institution on the other side of the world. The sonar data was classified for reasons of national security, and the site coordinates were mysteriously corrupted in multiple backup systems. When pressed for comment, government officials cited concerns about disrupting sensitive marine ecosystems. But satellite imagery from the same period shows no unusual environmental monitoring in the area. No marine biology expeditions, no conservation efforts, just empty oceans stretching to the horizon, as if the discovery had never happened at all. This pattern repeats with disturbing consistency. Archaeological teams working on anomalous sites suddenly lose access to excavation permits. Researchers studying genetic sequences that don't fit evolutionary models find their laboratory funding redirected to other projects. Linguists analyzing ancient texts containing technical specifications encounter unexpected obstacles in accessing primary sources that were previously available for decades. The message is clear. Some questions are not merely academically discouraged, they are actively suppressed. Why would contemporary institutions invest such energy in concealing evidence of advanced prehistoric civilizations? The answer might lie not in what these discoveries reveal about the past, but in what they suggest about the present. Because if human civilization has been guided by non-human intelligence throughout history, then the implications for modern society become staggering. Every government would face questions about what they've known and when they've known it. Every religious institution would need to reconcile theological doctrines with evidence of non-divine teachers. Every scientific establishment would confront the possibility that human achievement might be less independent than assumed. The economic implications alone would be revolutionary. Technologies that we consider cutting-edge innovations might turn out to be rediscoveries of ancient principles. Patents and intellectual property rights could become meaningless if the fundamental knowledge they're based on predates human civilization itself. Entire industries built on the assumption of linear technological progress would need to reconceptualize their foundations. But beyond these practical concerns lies something even more unsettling. The possibility that the guidance hasn't ended. That the same forces which shaped human development in ancient times remain active in forms we haven't recognized. The recent acceleration of technological advancement feels almost too rapid to be natural. In just over a century, we've progressed from horse-drawn carriages to space stations, from candlelight to nuclear power, from handwritten letters to global digital communication. This pace of change exceeds anything seen in previous human history by several orders of magnitude. Either we've reached some kind of critical mass where knowledge accumulation becomes exponentially self-reinforcing, or something has been actively accelerating our development towards specific goals we don't fully understand. The timing is particularly interesting. Our most dramatic technological leaps have coincided with official acknowledgements of phenomena that previous generations would have dismissed as impossible. Advanced materials that seem to violate known physics, propulsion systems that operate without visible means of thrust, communication technologies that appear to function across impossible distances instantaneously. Are we discovering these capabilities through independent research, or are we being guided toward them by intelligence that has been observing our progress and determining when we're ready for each new level of knowledge? The ancient texts suggest that such guidance operates according to carefully managed schedules. Knowledge is shared when civilizations reach certain developmental thresholds. Capabilities are withdrawn when their applications exceed safe parameters. Entire societies are reset when they advance too quickly or in dangerous directions. If this pattern continues to operate in our time, then we might be approaching another major transition point. The question is whether we're being prepared for graduation to genuine independence, or being evaluated for potential reset if we fail to meet the criteria for advancement. The evidence suggests that this evaluation is already underway. The gradual disclosure of previously classified information about unusual aerial phenomena. The increasing frequency of officially acknowledged encounters with technology beyond current human capabilities. The systematic release of genetic and archaeological data that challenges fundamental assumptions about human origins and development. These revelations aren't happening by accident. They represent a carefully orchestrated process of preparing human consciousness for information that would have been psychologically devastating if revealed suddenly. We're being acclimated to possibilities that our grandparents' generation would have found impossible to accept. But acclimated for what purpose? Are we being prepared for open contact with the intelligence that has guided human development throughout history? Are we being tested to see how we respond to evidence that challenges our assumptions about independence and autonomy? Or are we being given one final opportunity to demonstrate that we've developed the wisdom necessary to handle advanced knowledge responsibly? The ancient accounts suggest that civilizations face this choice repeatedly throughout their development. Each cycle brings them closer to genuine autonomy, but also closer to capabilities that could prove catastrophic if mishandled. The survivors of previous resets preserved warnings about this process, encoding them in stories and monuments designed to help future generations recognize the signs and make better choices. Those warnings are activating now. The patterns described in ancient texts are manifesting in contemporary events with increasing clarity. The choices that determined the fate of previous human civilizations are being presented to us with growing urgency. And for the first time in human history, we have the technological capability to document, analyze, and share this information globally in real time. We can compare ancient accounts with current events. We can analyze genetic and archaeological evidence with unprecedented precision. We can communicate discoveries instantaneously across all cultural and political boundaries. The question is whether we'll use these capabilities to break free from historical patterns or repeat the same mistakes that have reset human civilization multiple times throughout its hidden past. The silence is breaking. The pattern is completing. The choice is ours. But this time, unlike our predecessors, we know the choice is being made. We understand the stakes, we recognize the signs, and we have access to the warnings that previous generations tried so desperately to preserve. The outcome is no longer predetermined. For the first time in human history, we have the knowledge and the tools necessary to write our own ending to this ancient story. The only question that remains is whether we have the wisdom to use them.